We're going to continue with chapter 5, which is an introduction and more so, maybe I should say, a review of sine, cosine, and tangent. This is stuff that you've seen back in the day. Maybe it was 2 years ago, maybe it was 20 years ago, but it doesn't matter. We're going to go nice and slow like we did last time. And then next week, we're going to spice it up a little bit. So what we're going to do now is exercises from section 5.4. In these exercises, we're going to try to solve for the angle when you're given sides. Then, with the time remaining, I'll do some review of degrees, minutes, and seconds, just so that we can complete that topic as well today. Next week, we'll look at more questions and finish off the book. Most likely we'll finish the book earlier next week, maybe by the halfway point of Friday's class. So in the remaining time, I might just answer a couple of questions from chapter 6, which is it just continues. Chapter 6 is a continuation of chapter 5. It just that the questions get harder. That's all. So let's get going here. Excuse me. We will begin with this example. So in this question here, we're asked to find both of the acute angles in the triangle. So it doesn't matter which angle you solve for first. So without any preference, I'm just going to pick the one that comes alphabetically first. In the Greek alphabet, this letter comes first, theta. So if I choose this letter here, this angle, let's say that you choose this one. You're still going to get the same answer. It's just that your statements are going to look a little different. The path to the answer will be different, but the numbers at the end will be the same. So if we choose this angle theta, then we proceed to label the triangle. So this guy over here is the hypotenuse. It doesn't matter what angle you choose. This is a right angle, and the hypotenuse is always across the right angle, or if you want, the hypotenuse is the longest side. Then, because we chose this angle theta, this will be the opposite, and this will be the adjacent. So what I'll do is, I'll write down SOHCAHTOA here, but I'm not going to write it down every single time. So I'm going to ask you for a favor. I want you to jot this down on a sheet of paper in front of you and have it on file for immediate access. So that when I say to you, what should we use? You're going to have this in front of you and say, oh, we should use this one or whatever. In this case, we have numerical values here and here. Since those numbers are over on those quantities, on the opposite and the adjacent, we're going to use the tan ratio. So if we write down the tan ratio, it'll be tan of theta. I'm going to do this with the keyboard, the actual typing of the numbers, and leave the drawing to the stylus. So here we're going to get tan. Hopefully you had a good week, and we're just continuing on that vibe right now. So tan of theta is opposite over adjacent. In this case, opposite is 53.4 meters, and adjacent is 117.0 meters. I'm going to turn off the video here. It might slow me down on the recording. Okay, you can still hear me, I hope. Please confirm that you can hear me. Thank you. All right, how do you solve this? Who remembers what to do here? Can someone kind of give some hints to the class there in the chat? What do we do to solve this thing? Anybody remember? So when you solve for the angle, you must take what's called the inverse. In this case, the inverse is this. Who remembers seeing this on their calculator or using this type of feature with the -1 there? Okay, thank you, Amira. Anybody else? That's one person out of 24. Anybody else remember that button? Okay, thank you. Okay, so I'm gonna do an extra step here later. That is correct, Maha. Thank you so much. What I'm gonna do is I'm gonna take the tan here, and it's gonna sound a little bit like it's not really appropriate, but I'll do it to start. I'm gonna take the tan and somehow we move it to the other side. Okay, it's simply because I'll talk to you about that in a little bit. Let me just finish answering the question for here. I'll finish answering the logic for that in a second. So I'd like you for a second now to take your calculator and make sure that you get the answer that's being reported in the chat. Thank you, Maha. Thank you, Shalon. You are on point there, my friends. So that is definitely the answer that I was hoping for. This part here, notice that I didn't really turn this into a decimal. You see, you don't need to actually, this number here, you don't actually have to turn it into a decimal. Yes. So when you're finding the angle, you use the inverse. So I was gonna actually talk about that or right now. So the basic idea is this, okay? If you want a side, then you use sine, cos, tan. If you want an angle, you use, got it? Matthew, what's up? What's up, Matthew? How about when we get toward the break, okay? When we finish these questions, I'll pause the lesson. We're going to do about 4 or 5 questions right now. I'll pause the lesson after that, and we'll discuss anything that you have about the assignment. One thing I notice here is that this ratio here, you can turn it into a decimal. But is there a benefit to writing that as a decimal first? In my opinion, no. If you wrote this as a decimal here, whatever that is, 0.4 something maybe, I don't care what the decimal is because I'm going to put the same decimal right here. So usually what I advise people is do not bother making this a decimal. A, you're wasting time, and B, you're also introducing potentially some loss of accuracy in your answer. Let's say that you round this here, and then you put the number here that was rounded, and automatically you've lost some accuracy there. So maybe when you get to the answer, you don't get 24.53, which is the most accurate answer that we want, because it's to 2 decimal places. Maybe you get an answer that's a little bit off. I mean, on an evaluation, it's not a big deal, but in practical circumstances, it makes sense to try to be as accurate as possible. So now that we have the angle theta, can someone inform the class how we would finish solving this triangle? How would you find the other angle up there, that Greek letter? Phi. How do you find that angle up there? Anybody there? Let me know. You could use cosine, you could use sine. Yeah, you could use any of those. But is there a cheaper way? What's the cheapest way? Very good, Maha. Yeah, you would use the 180 rule. Maha, I'm gonna write down a little bit different than yours, but what you wrote down is beautiful. So I'll do it as a 180 first. You could do 180 minus 90 minus 24.53, and that would give you 65.47. Or you could use complementary angles and just do what Maha did in the chat there, which is 90 minus 24.53, which is equal to that same answer. So I don't really, I'm not too concerned if you do it this way or this way. But the thing is do whatever you're comfortable with. So there we go. That's our answer. We got our angle here. I'll just highlight this one just because it's the first answer that appears along the list. And hopefully that was a nice and slow introduction to remind you about how you do these things. One last thing before we move on to the next example. As I mentioned last time, you have meters here, and these meters cancel. So it's important that you understand that the number in here, there's no units to it. It's a ratio, because all of these functions, sine, cosine, and tangent, describe ratios. So on to the next one. Here we go. I'll just keep this panel open on the side. Hopefully that's font is large enough for those that are coming in late. So here we go again. This is your opportunity to learn the Greek alphabet today. We have alpha over here and we have beta over here. I don't care which one you solve for first. It shouldn't matter. Yeah, and you can use that to find the side if you need to as well, Denny. Yes. So all the questions that we're doing today are targeting the angles. And then next time, or if not by the end of today, we might look at questions targeting the sides as well. And then next week, and then the following chapter, it's going to be all scrambled, and then you have to kind of figure it out each time. I'm going to go for alpha first. So can someone tell me, this is the hypotenuse. Relative to alpha, is this opposite or adjacent? What's that one there? Thank you. I'll put a box on it because sometimes people think I'm writing a 0. They're like, sir, why is the side 0? It's not 0, it's opposite. Anyway, let's write down the ratio. So you have, remember on the side, I wanted you to write that on scrap paper, SOHCAHTOA. What should we use here? Sine, cosine, or tan? I want to see someone else, someone new in the chat. Oh, Shalon, you're not new, but thank you. Okay, thank you, Danny. Thank you, Bilal. I saw your answer there. I appreciate that. So yeah, we're gonna use sine here. I'm gonna newer, maybe. Denny's newer. Denny is newer. Shalon is pre-owned. Like when you buy a car, it's a used car. They say pre-owned. It sounds better. Make you want to pay a little bit extra, right? And when I first heard that, I started laughing. This is like 20 years ago. They started saying pre-owned. I was like, yeah, okay, buddy, it's used. Never mind. Okay. Anyway, here we have 4 feet, 3 gently loved. Yeah, whatever, right? 4 feet 3 inches, 4 feet 11 inches. I'm gonna tell you a story during the break about when I bought my first car, and you guys are gonna find it really funny, I think, because I think it's hilarious. I think it's hilarious anyway. We have a little bit of a hiccup over here. See this thing? We got feet and inches here. What the heck do you do there? Yeah, and please go to inches. Do not go to feet because you're unnecessarily introducing decimals. Do not go to feet here because you're making decimals that you don't need to. So what is the numerator in inches? Yes, you can, Ram. Absolutely. If you want to get beta, then you use cosine. So if you want to get it, if you wanted to get beta, you could use cosine. So how do we move this over? How do we move the sign over? What do I write here? Tell me what to write here. What operation? Not the answer. Not yes. Thank you, Ram. Thank you very much. And then in the brackets, 51 over 59. Can someone type that on their calculator? Thank you, Amira. And thank you, Maha. You're doing all my work for me. I love it. I can't pay you all though. I'm gonna be like going backwards here in my career. Anyway, okay, here we go. We got alpha. You could use cosine or tan to get beta, but it's the most efficient way to use the 90 or the 180. So I'll do the 90 rule this time, if you guys don't mind. So beta is 90. So I'm doing it the way the Maha did earlier in the chat, which is the more economic way to do it. This is mental math. So if you're like, how do you do that in your head? Just pretend that's 60. If you pretend that's 60, then the answer would be 30. But then you have to add 0.18. So you can do these operations in your head if you train yourself a little bit. Not too much. I realize it's Friday. We don't want to damage too many brain cells. Okay. So that's that. Are there any questions about this this example? Let me know in the chat on a scale of 1 to 10 how you feel about this. 10 meaning that you're amazing and 1 meaning not so amazing. Where are you at? You don't have to answer. This is optional, but just give me a number from 1 to 10. We only have 3 people answering. Okay. So I'm assuming everybody else is a 1. No, I'm just kidding. Just kidding. No. All right. Well, if you're not at a level of 8 or 9 or whatever, okay. I like your humility. I like that one. Hilarious. Thanks, Ricardo. Very kind of you. I'm gonna keep on going here, but my goal with you is by the end of the next few exercises to get you all to an 8 or a 9. So hopefully, if there's anything in here that is annoying for you in the process, we can remedy that with the next example, which is another one with mixture of feet and inches. So let's label this thing, and then we'll talk about the analysis. So here's our hypotenuse. That's always the hypotenuse because it's opposite the right angle. Is this opposite or adjacent? What do you think? What do you think, people? Opposite or adjacent? Don't make me sweat for it. Thank you. It's adjacent. Remember, the word adjacent means beside. And this side here is beside the angle. This one is opposite, and we definitely don't want opposite. Which ratio should we use? Sine, cos, or tan? Yeah, cosine's the way to go. Cos is equal to 6 feet 2 inches, 6 feet 8 inches. I don't like those units. Let's get those into inches so that it's easier to divide the two numbers on a calculator. 74, yep, and 80. How do we get rid of that cosine? It's okay. You had the right ratio. It's just upside down. How do you get rid of the cosine? How do we get rid of that cosine, people? Thank you, Shalon. Yep, thank you, Danny. You're going to write a -1 there, I think. I'm assuming that is a -1 there. Fantastic work, everybody. So looking at the answer key, I just have the final numbers in front of me, so I don't want to, I'm letting you do all the work here. And I got the same number on my notes on the side. So thank you, Shalon. We are good to go. Look at that. So remember, if you want to find the angle, means taking the inverse. Don't forget that. So I'm going to talk to you about, yes, that's good to know. I'm going to talk to you about stuff now on the side here. I want you to think about a little flow chart, okay? You could have sine, cos, or tan in this box. I want you to think of it like a machine. I don't care if it's sine, cos, or tan. Just we're using cosine because the question here involves cosine. If you want to use cosine, the input is an angle and the output is a ratio. And if you want to use cos inverse, then the input is a ratio and the output is an angle, which is exactly what we have in these circumstances here. At least the questions that we're doing so far today. I need to really thicken up this highlighter. We're using this one down here. So that's all I wanted to kind of ramble on about for a little bit there. Hopefully we're building up your confidence level so we can move on to the next one, which is a compound figure. Compound figure. So here we got to do a little bit extra work because this triangle is okay. This triangle is no problem. Let me put a 1 here. This triangle is easy because you have two sides and you can get x and y. And we'll do that shortly. But then the second triangle, we have a little bit of effort involved. We need to figure out this length here. So this length here, I'll just put I'll put it in red. Can someone tell me what number goes in this box here? What is that length there? Give me 3 decimals, please. It's going to be 190 something probably. I'm just guessing it now. 190. I'm trying to do it in my head. 196, is that right? Wow. Not bad, eh? Not bad at all. I still got it, my friends. Still got the gift. Okay. Anyway, how did we get that? How did we get that? I'll put a star here. How did we get that answer in red there? What did you use? What method? What approach? How did we get that number in the box there? Please let me know in the chat. Did we use sine? No. We used the Pythagorean theorem. Good. So remember that just because we're solving for angles does not mean that we throw away the Pythagorean theorem. Thank you, Mike. We still keep all of that, okay? So in this case, now we're ready to go with the actual question. So we need to talk about the first triangle, for example, and then we'll do the second triangle. In the first triangle, we have x and y. Can you please pick either x or y? I don't care which one you pick. Pick x or y, somebody. Sure. So we're going to pick x. If we pick x, then this one is opposite. And this one is adjacent. I'll stop there and then type out the rest for that first triangle. So, opposite and adjacent, is that sine, cos, or tan? Which one? Yep. So tan x is equal to 42 over 192. I'm being a little bit lazy with the units now because I think we've established that the units should be consistent and then they cancel out. So to move over tan, we would write tan inverse. And we already have an answer there, so that's good. Okay, I'm going to go with 2 decimals. My keyboard is glitching here. Like, sorry, PowerPoint is glitching. Just give me a second. I'm going to close and reopen the file because it's doing some funny business. So it's a little bit frustrating when I'm trying to teach you. Yeah, it's still doing the same glitch. Very strange. Anyway, so 12.34. How do you get y? How would you get y? Or what is the answer for y? You could use sine, but your cheapest answer is to use the triangle's angles. See, we know x and we know the right angle, so we could use 180 or 90. I'll use the 90 rule. Thank you, Ram. I'll use the 90 rule because it's cheap. So that's 77.66. Okay, so there you go. There we go. That's triangle number one. Let's go with triangle number two. I got my whatever color that is. Looks like a fuchsia or something. I'm gonna say that. Okay, you tell me. What do you want to get? You want to get Z or W? Pick. Pick one of those. I don't care which one you pick. Shouldn't matter, right? Okay, we're gonna get Z. So if we get Z, then this is the hypotenuse. And I know that the picture is really like rotated and it might get you dizzy there, but look for the right angle. The right angle is easy to locate, and it always tells you the hypotenuse. And then this side here, which is in red, is going to be the adjacent. So that is a way to kind of get through the question without too many headaches. So let's go through triangle number two now. So it's adjacent, which is cosine. Cosine of Z is 196. So what does Z equal? Yeah, I got the same. Thank you, Ma. And W will be 90 minus that. Which is how much? Again, you should be able to do that in your head. Just pretend it's 46. If it was 46, then the answer would be 44. But you have to take away one hundredth. If you think of it honestly, for those of you that are like, I don't want to do this in my head, think of it as money. If this was money, you could do this in your head. I know you could. If this was money here, you could do it in your head. You'd say, I have $90 and I'm taking away $46.01. And then you're good. Now, if you say to me, even if it's money, oh boy. Okay, I'm inviting Amira to a poker game. Bring as much money as you want. You'll probably win anyway, so it doesn't matter. Yeah. Actually, if you ever like play any board games, like anything, like Monopoly or whatever, and whenever someone shows up to a board game, they're like, "Oh yeah, I've never played this before." They're lying. They just wanna make you look bad. Yeah. You don't want to play board games with me. For me it's full contact. I drop elbows on people. And I can't stand cheating. No. I wasn't born with a built-in calculator. Come on. Come on. All right. It's your turn. Your turn to shine. I'm gonna give you guys oh no, I have board flipped one time, but it was because when I used to play with my sister and her best friend, they would cheat and I would catch them. And it was so like I was so cheesed because they were cheating. I knew they were cheating. Yeah, cheating in Monopoly is okay. I mean I realize that now. And working with playing with my niece or nephew, those kind of board games, I have to realize that as a grown person, I have to lose and I should let them win, even if I'm winning, because you know, it's just a good thing. Anyway, you got to give them confidence. But even in saying that, they still beat me fair and square. Okay, I'm gonna pause the recording for 5 minutes. I want you to try this question on your own, and we'll take it up. So we'll take this question up in 5 minutes at 10:41. Let's get this party started again. It says here to find both angles. Well, one of the angles is not labeled, So I'm gonna, thank you, Matthew. I'm gonna label this thing here. I'm gonna give you, who wants to learn some more Greek letters? Let's put another Greek letter here that you haven't seen before. There. The Greek letter Xi, spelled Xi. It's like it's pronounced, you say it like the Greek, like the letter X in English. Anyway, just having some fun with you there. Let's solve for theta. So if we go for theta first, then this is opposite and this is hypotenuse. So is that sine, cosine, or tan? Please let me know. Sine, cos, or tan, what is that? Thank you and thank you. I will catch up to your awesome comments. So sine of theta is equal to, Amir, your answer is very, very precise. I love it. Okay, 27.2 divided by, I don't have the answer in front of me for this one, like the final answer, so I'm relying on your amazing computational skills. By the way, if you don't have a calculator that does this, the last thing you want to be doing on a test is using your iPhone or your Samsung or whatever it is. You need to have a proper scientific calculator because using your phone for this really is not fun. Why do you get an error? Maybe you need the brackets. Maybe you need brackets when you type it. Not sure. Parameters out of range. But if you had the, oh yeah, shift, yeah, use the shift. Well, it doesn't matter if you use shift, you're gonna get some garbage answer if you don't use shift. Okay. What kind of calculator is it? Casio. I don't know. Anybody else have a Casio, the same kind? Because were you getting the other answers right? Thank you, Denny. Were you getting the other answers right there? Honestly, maybe just throw your calculator at the wall and then see. I'm just joking. Do not do that. That was a joke. Yeah. Maybe just reset it. Thank you, Amir. In the bin, I know. If I show you the calculator I had as an engineering student, it was like yeah, I would definitely do that. When for engineering, they did not let us have any fancy calculators, and even the calculators that we had, they were so basic. If you had to use this in like an architecture, like in a work environment, you would want to break this calculator in half. Let me show you this calculator. This one here. Can you see that? Who has this calculator? Yeah. If it's this one here it's a great calculator. I've had this calculator for 20 years. I'm not dissing the calculator. And it doesn't matter what the calculator is. If you don't know how to use it, it's you. It's not the calculator. But sometimes the calculator has settings that are weird, and you can't really type things in nicely. It's nice when the calculator has a dual display. If you're wondering what calculator I like, I definitely like the ones that have the dual displays because then you can see what you're typing and you can see the answer as well. It's nice when it works, definitely. So anyway, I hope that you had a good experience. We managed to get through the required exercises. This one here is a table interpolation question. Do not worry about this. We skipped this section. And I mentioned that already. And if you're wondering how do I know what I skipped or not skipped, I've posted the handwritten notes, like these annotated notes on Blackboard. So if you go to the notes that I posted on Tuesday, you can see that I bleeped out a few pages and just said, don't worry about those ones. They use a traditional way, which is without the calculator, how people used to do it many years ago when calculators were not as widespread in use, or they were just prohibitive to have, maybe because of cost at the time. Okay, I'm glad that it works, because that would not be fun. So what we're going to do now is talk about degrees, minutes, and seconds for a little bit. And I'm going to just shift you down to page 23, because I did give you a lesson on degrees, minutes, and seconds already. We actually can just jump into the exercises. So remember, these guys over here, these are degrees, minutes, and seconds. So we'll do one conversion of each, and then I'll do the two exercises that are presented here. So to do that, I'm just going to have to insert some extra slides here. So just bear with me for a second, everybody. Apologize for this delay. When I prepare the recording for YouTube, I'll edit out all this blank time, because nobody wants to see this being live. Okay, so we're going to do one of those, and then we're going to do one of these. So let's go through this quickly, but nothing too dangerous. I'm going to do the first one here. It says convert the angle to decimal degrees. So I'll do the first one, which is in degrees, minutes, and seconds. And then I'll do the first one of the second batch as well, which is in decimal degrees. So remember that degrees, minutes, and seconds is just like time. 1 hour has 60 minutes, just like 1 degree has 60 minutes. So this is degrees, minutes, and seconds. So you can convert that into degrees as a decimal value by doing the following operation. I'll do it over here. So I'm answering part A. Just part A. This would equal the following: 7 plus 54 over 60 plus 12 over what? What goes down here? What goes down there? Very good, Maha. I like your answer. You could do it this way, or you could do it this way. Both ways are beautiful. I don't care which way it is, because they're both equal. No, it's good. Good work. Can someone give me a value for that, because I do not have these answers in front of me. I don't have my calculator, and that calculator that I showed you is not the best to do these operations. So what do you get here? To 3 decimal places. Anybody? 7.903. Thank you so much. Perfect. That's excellent work. Thank you very much. So if you're like, why is there a 60 here? Because it's just like time. Think of the 54 as being minutes, and when you want to convert to hours, you divide by 60. And then if you want to go for seconds, you know that there's 60 seconds in a minute and 60 minutes in an hour. As Denny's pointed out there, that means you got to use 60 squared, or 3600 if you just want to write it down cheaper. I like this way myself, but this way here is just to verify that you understand that it's 60 squared because of 60 minutes and 60 seconds. To go the other way, it's a little bit annoying, but I'm saying it's annoying if you do not use any special features on your calculator. So on just doing this by hand, what you can do is do 38. 38's good. So 38 degrees. You don't have to write all the stuff I'm writing. Just bear with me, okay? 60 squared, because you wrote down 3600 earlier, right? Shalon, you wrote down 3600. That's what 60 squared is. 60 squared is, sorry. Continue your thought. You're welcome. So the 38 degrees is easy. You put in the bank. Now you take the 0.652 and you multiply by 60. And what do you get when you multiply 0.652 by 60? Can someone tell me, please? Because I don't have my calculator in my hand. What's that equal to? 39 something. Thank you, Amira. So now you know that you have 39 minutes. And then you take the 0.12 and multiply. Whoops. Get that here. You take the 0.12 and you multiply by 60 again. And you get 7.2 seconds. And then you can take the 7 and put that in the bank. You're just rounding it here because it says to the nearest second. And then the final answer is 38 degrees, 39 minutes, and 7, whoops, that's a 7 seconds. So that's kind of how you do it. It is reminiscent of how you do this multi-stage approach for finding feet and inches, or feet, inches, and quarter of an inch, things like that. So when you want to do degrees, minutes, and seconds, your calculators have buttons that are dedicated to this type of process. So case in point, this one over here. See this button here with the quotation marks? That's degrees, minutes, and seconds. And this button over here. I use these two calculators as the examples, but there's many calculators out there. Because in my experience, when I walk around the classroom, oh shoot. It's on the screen. I'm sharing my screen, Malik. You should be able to see it on your screen. I'm not sure why you don't see the screen, but can people see my screen? Okay, yeah, because maybe sign in and sign out. Okay, good. So these buttons here allow you to figure out degrees, minutes, and seconds. So you see the stuff that we did here by hand? See all this stuff that we did by hand over here and over here down below? Even this, look at this. This is not fun, right? We actually have calculators now that you can do that. So anyway, if you're like, how do I do it on my calculator? I'm going to leave that up to you to figure out. If you go on YouTube, someone's made a video about it. I promise you, okay? I can't make a video for each calculator because I only have like one calculator in my desk here. And then I have another one that looks like it's much more advanced than these ones. So it's kind of pointless showing you something that you don't have the same model as me. So anyway, if you want to know how to use these buttons, they're fairly easy to figure out, but you can just hook up a YouTube video or somewhere, or maybe just if you Google search videos and you say DMS, degrees, minutes, seconds, and the calculator model, you should be able to locate some information. So on to the next question. So if you want to solve for theta here, you can use that special button on your calculator, or you can just do things by hand with basic arithmetic, as I've been doing with you anyway. Relative to theta, this one's opposite and this one's adjacent. This time I didn't bother labeling the hypotenuse because we've done enough of these today that you're probably feeling good about them by this point. So now it's time to just do some calculations. Which ratio do we use? Sine, cos, or tan? Tell me. Because you're students at the college, you do get Microsoft Office as part of your tuition and fees. I highly recommend that you start trying to do mathematical formulas like this on the keyboard, like with your Word or PowerPoint documents. The reason I suggest that is because it really makes your life a lot easier, especially with digital technology. See, I have a stylus here where I'm drawing stuff, and even that thing is pretty slow to do. If you can figure out how to type all this stuff here, it's actually really, really efficient. And I've noticed that with some of your assignments, people do type them, and I really appreciate the level of professionalism in that. Although you don't have to type your assignments for me. But I'm just saying that if you do it this way, it might actually save you time in the long run. So, did someone get an angle here? Anybody have an answer for this in degrees? Okay, 28.33. Can you give me more digits, Donato? Can I have some more digits on that? 28 point, if you don't mind. You're a champ. Thank you. That's perfect. I'm going to go with 4 decimal places, and then we need to get this to minutes. To convert to minutes, take the 0.3305 and multiply by 60. When you do that, you're going to get approximately, is it 20? Is that right? 20 minutes? It looks like it's a third. It'd be around 20, no? Can someone confirm? Yeah, so 20. Thank you, Bilal. So I will definitely go with 20. So that gives us 28 degrees, 20 minutes. So let's say that obviously your second test is not for a while, at least a month, I think now. I think it's a month from now. But in any case, if you get, let's say this question was on your test. I want you to get this answer. Make sure you write that down. Make sure you write that down, because then that is a huge milestone. This thing here, yeah, it's annoying to do, but it's small stuff. The big part of the answer is this. And then this thing here is decoration. This is just communicating it a specific way for the audience, for me, in other words. I just want to make sure that you don't panic and you kind of get here and then you're like, I don't know how to do minutes, and you just drop the question. So that's all I'm saying there is get the easy stuff out of the way first. Okay, here we have another one, and it's another question involving fractions of an angle with minutes and or seconds. So here we have opposite, whoops. And here we have hypotenuse. So which ratio should we use? Sine, cos, or tan? Any thoughts? Yeah, sine is correct. So sine of this Greek letter phi, we've seen phi before, is 12.6 over 87.9. So then phi is equal to sine inverse of this. If I convinced anybody here to stop typing this as a decimal and just to leave it in the brackets, who likes this? Who never did this before? And who likes doing this now? Like, you don't write a decimal, you just leave the whole thing as a fraction and save yourself some writing. Who likes what I'm doing here? Maybe I've convinced you to do it a little bit cheaper this way and safer. Anybody appreciate that or whatever? Okay, cool. All right. So we got to get this into a decimal value. I did this one earlier, so I have some scrap paper beside me. 2, 4. Sorry, I'm trying to type and read at the same time. This is exciting. I actually did it to 5 decimals this time. I guess I was enthusiastic when I did this earlier. So what you want to do now is convert to, no, it doesn't have to be 5 decimal places. 4 decimals is enough. 4 decimals is enough because, let me explain to you why 4 decimals is enough, okay? 1 over 3600 is greater than 1 over 10,000. That means that 4 decimal places is enough, okay? Okay, back over here. So if I go 4 decimals, it's fine. Anyway, if we take here 0. What do you get when you multiply that? Can someone confirm? It's 14.49 or 48. What is that? Can someone confirm that number, please? Thank you. And then take the 0.48 and times it by 60 seconds. And 48 times 60 is roughly 28.8. So it says nearest 10 seconds. So the final answer is going to be a little bit shifty here. It's 8 degrees, 14 minutes, and 30 seconds. So don't be too confused about that one, please. It says the nearest 10 seconds. So that's why I made it 30 here. And there you go, my friends. Exciting times. Degrees, minutes, and seconds. So anyway, hopefully this is not too dangerous for you. We have one more to do. And this one here, I'm going to do it without the special button on the calculator, as I've done every question without that special button. But definitely, if you know the button, it's a lot easier to play. So what you want to do here is get alpha. Well, I've used basic operations. The only operations I've used are add, subtract, multiply, and divide. I did them a little bit ahead of time so I don't waste time in front of you in class. But the only thing is I'm not using the fancy button, the one that I've highlighted here on these calculators. I haven't used those fancy buttons because hilarious. Okay. Let's find the angle alpha. Can someone tell me a strategy? Let me know in the chat. What would be your strategy? Explain to me or tell me what to do here as a strategy for this question. No freaking out. Come on. Yeah, you could change it to degrees. I'm going to do this, people. I'm just going to take the two numbers and I'm going to go and do them like I did back in grade school, back in the day. I'm just going to add them together. So if you do that, what do you get? 80, 90. I'm doing this in my head. Sorry. What was that? 70, 85? 85 degrees, 35 minutes, and 83 seconds. Can someone confirm those three numbers, please? Cool. Let's fix that. What's wrong with this? What's wrong with this this answer here? The 83. Thank you, Denny. So I'm going to make that a 23 and make this a 36. You see how I carried it over? Okay, perfect. Now, step one is complete. Now we have to do the second step, which is to do 180 degrees, and then take away this. But we don't have a way of doing that. We don't have a way of doing that because we need to borrow. So we should borrow first, okay? So this one's no good to us. So we'll redo it as this statement up here, exactly. 170 degrees, 59 minutes, and 60 seconds. And I think at this point, whoops, I think at this point we're good to go. Yeah, I'll fix that in a second. Thank you. Thank you, Denny. I meant to put a 9 there. Gotta love the keyboard skills here, eh? Okay, what's 179 minus 85? Is that 94? I think so. 94, that looks like a 23, and that looks like a 37. Yay, that's the answer. Fantastic, everybody. Fantastic. So there's the process. I hope that it made sense. It's something that on a test, I'm not too worried about if you use the button on your calculator or do it by hand, but you should be worried about the risk involved. What I mean is that, let's say that you use the button on your calculator and you just write the answer down. You're taking a risk by not showing me any work. So maybe a compromise is needed. So if you're going to use the button on your calculator, perhaps show me something in between. Like tell me this number here, or tell me this number here, or show me that you write this down just to show me that you understand what the calculation is. So that's the small things I'm asking from you. They're not there to annoy you, but they're there as a safety net for you in case you make a silly mistake. And I have no clue if it's because if your answer is wrong because you don't know what you're doing or because you made a silly mistake. And I'm not a psychic, as you might imagine. Anyway, we've completed the lesson that I needed to cover with you today. I'm going to leave the next section for next time. I'd like to maybe do one question with you, but I also wanted to have a little bit of fun with you today by doing something a little bit different. So perhaps we can try something a bit more challenging. Yeah, we have an assignment that's due today, Malik. There's an assignment that's been on Blackboard since Sunday. Yeah, it's been on Blackboard since Sunday, my friend. You have time. It's not a long assignment. 2 questions.